guys, welcome to my YouTube channel. In this video I'll be sharing with you the evolution of software. So please subscribe to my YouTube channel right now and hit that bell icon to be notified each time I come up with a new video. The process of developing a software product using software engineering principles and methods is referred to as the software evolution. Now, this includes everything from the development of the software initially, and its maintenance, updates, until the entire software product is developed and reaches the place of satisfying the expected requirements, initially set up for that software product. Software evolution starts from the requirement gathering process, like what the software is all about, what is the intent of the software, what do it stand to achieve from this software product. So that's where the entire evolution of or software product start from. And after this process, it's the time that developers create a prototype, sometimes called an MVC, of the product, of the intended software product, show it to client or users to get their feedbacks, at the early stage of the software development process. The users then can suggest changes, on which several updates and maintenance and configurations can be made, during the review and feedback process time. And this process changes to the original software, and will continue until the desired product is achieved or accomplished. Even after the user or client has made the desired software changes and they are already satisfied with the product in their hand, there's also something that can push or change in the software, like for the advancing in technology every day, the changing requirements of the software product, according to the users, need. Maybe there will be scalability, and then the user, requirements will rise. So you have to make changes. So recreating the entire software product, from scratch, to go one to one with the requirement, it's not something easy. It's not something cheap or feasible. So there is, one feasible and economical solution to update the existing software. So that is, to cause it to match with the modern, like the recent updates, like the recent changes in software, in technologies, or in the users or requirements. You have to do updates. So software updates can be the most economical and feasible solution for maintaining the product after it has been achieved and accomplished and satisfied by the users. And there are some laws that talks about software evolution. I'll talk to you about them in a second. Lehman has given laws for software evolution. The laws describe the balance between forces driving new development, on one hand, and the forces that slow down the progress on the other hand. He divided the software into three different categories, which I'm going to talk to you about in a second. First, he talks about the S-type category. The S-type, which is the static type, this is a software which works strictly according to defined specification and solutions. That is, the solutions and the methods of achieving it, they are all, understood. They are, set up. Everything is set before going out to the computer and start to actually code the program. So that's the S-type program, and this type of program is usually subjected to changes, since it is the simplest of all, it's easily manipulated. You can change things into it easily. So an example of such type of program is, for instance, a calculator that can calculate salaries, for example. These are programs that fall under this type, the S type or the static type. He also talked about the P type. The P type is the practical type. This is a software with a collection of procedures. This is defined by exactly what procedures can do in the software product. In the software, the specification can be described, but the solutions It's not obvious. You all have the specifications, you know what you want, the requirement all set, information gathering process, everything went out and everything is cool. But the actual solution of achieving those set goals is not so obvious in practical time. Software evolution. A good example of this type is a gaming program, for instance, a game program. You will know what you want in the game and set all your goals and other things, but achieving it can be a kind of obscure. It's not so clear. The next one is the E type or the embedded type. This is the more condensed one, because it has a more deeper, information regarding it, and is becoming practically the most common ones around, and everyone is getting to it. We'll get to know more in a second. The E-type or the embedded type, this is software works closely as the requirement of the real world environment. So as things are changing, technology is changing, user requirements, people needs, advancement in other sectors, you will notice that you have to keep changing along. This software has a high degree of evolution, as there are various changes in laws, taxes, user requirements, social needs, and everything. So you have to keep changing it as things are changing. A good example of this type of software is an e-commerce software, or maybe an online trading software, for instance, Amazon.com or maybe Alibaba, or how do we call it, or Chomia and other things. There are a lot of them out there, and these must be changing, as the requirements and the technologies, the users' needs and everything is changing. They have to keep growing as taxes, and laws are also changing. They are the most maintainable and working, like they are the ones that require the most hands on deck. Lemon further, has divided, like he presented laws to guide E type of software, because it's the software that has the most dynamics, the most changes and everything. And for this one, he has outlined at least eight laws that can be strategically followed and to achieve the E type software evolution chain. You won't have any issues. So the first one is the continuing change. you know an A-type software system must continue to adapt to the real world changes, just as I said earlier, else it becomes progressively less useful, because as the world is advancing, technology is advancing, people minds are growing up big, and the expectation is getting higher. You have to grow along with them, so you have to keep in mind the continuous change aspect of the E-type or the embedded type of software. The next one is increasing complexity. As E-type software system evolves, as they grow, the complexity tends to increase with them. Unless work is done to maintain or reduce it. Like for instance, Amazon started their business, they were not so big, but as things started to grow up, users started to get more, started to throw up more requests, they want more, and Amazon started growing, all the kind of things. They needed manpower, they needed people to come over board and handle that data, because the information was getting too big, and the complexity of maintaining it when it just started, they could not keep up that way. So they had to get people to come on board to maintain it and reduce the complexity. So mostly E-type softwares, they are having increasing complexity, because as changes occur, the complexity of maintaining that product or software increases a lot. And another one is the conservation of familiarity. The familiarity with the software, or the knowledge about how it was developed, why was it developed, in that particular manner, and so on, must be retained in the system. So the purpose of the software must be retained with all the changes, all the different complexities that will come about. You need to maintain the purpose of the software. That is one good thing. Another one is the the continual growth. In order for an E-type system, an E-type system intended to resolve some business problem, its size of implemented changes grows according to the life changes, like we said in the increasing complexity, or bullet points out there I talked about earlier. As the system grows, the size, the implementation changes according to lifestyle, the change of business, and everything, like it's just an evolving system. It just changes depending on what's unfolding at the moment in the environment. Another one is reducing quality. Any type of software system declines in quality unless rigorously maintained and adapted to changing environment. So if you do not follow the first few bullet points that we talked about, you obviously reduce quality. If you reduce quality, means you will lose your product and nobody will use it. It will become, rendered useless in no time. So you have to, keep up with the changes, keep up with the environment, the operational things and everything like that to continue to stay, in business. And one great thing about E-type software that should not be forgotten is the feedback systems. The E-type software system constitutes multiple loops, multiple level of feedback system, and must be treated as much to be successful or successfully improved or modified. You know what I'm saying? Like you have to have a system to receive, feedbacks or suggestions or business, or let's say to receive information from your users or your clients about your software product, where they're having glitches, where they're having issues, and where we can improve and all that kind of things. So a feedback system is one the thing that keep the E-type system software running so strong and keeping it up to date, because you have to know what the users out there need, and to know what they need to talk to you. So the feedback system can create that channel for you to communicate with your users or your clients. The next is the self-regulation. The E-type system evolving evolution process is self-regulating with the distribution of products and process measure close to numbers. So you have to be self-regulating all the kind of information. The next or the final one is the organizational stability. The average effective global activity rate in a evolving E-type system is invariant over the lifetime of the product. So you have to check out the organizational stability, know what you are up to and everything like that. So next I'll be giving you an overview of the software paradigm. We'll talk a bit more about software paradigm. Hope you enjoyed this video. Thank you all very much for watching. I appreciate you. Please subscribe and stay tuned. Love you all.